fundamental theorem of calculus, it just doesn't even make any sense. Like, why do we have to do it? Hi, I'm a calculus student and I have no idea how to do the fundamental theorem of calculus. Can you help me learn it?
Yeah, I'm Isaac Newton. I can definitely help you learn the fundamental theorem of calculus, and it's used to show the relationship between derivatives and integrals, and it can help you find the area and distance of specific integrals, and then you can also use it to think backwards and find the antiderivative. So it helps you reverse tasks you already know how to do.
Okay, but what would the problems even deal with?
Well, you may see problems dealing with things ranging from density to probability to motion. It ranges lots of different
Okay,
problems.
that makes sense. Can you show me how to do the math?
Sure. The fundamental theorem of calculus part 1 is just substitution. So if you have an integral, or you're finding the derivative of an integral, so the integral of 0 to x, and your function is t plus 2 dt. All you have to do is you're plugging in x for t, and it's the derivative of the integral, so the answer would be x plus
Oh wow,
2.
it's really that simple?
Yeah, it is. And then, you take the derivative of this and times over this, but since the derivative of x is just 1, you wouldn't do anything. But for another example, if you had 0 to x squared, don't forget that, and it still is dt. So you'd still plug this in, so it'd be x to the 4th plus x squared plus 2, all times the derivative of x squared, so 2x.
Oh, okay. I think I could get the hang of that.
Yep.
So what's the second part of the fundamental theorem of calculus?
Well, part 2 is if f is continuous on closed interval a and b, and capital F is any antiderivative of f, then the integral from a to b of f of t equals antiderivative of b minus antiderivative of a.
Oh, okay. Can we do an example?
Yeah, I'll definitely show you one.
Okay.
Here's the problem we're going to do. So intervals 1 to 4 with the function x squared plus 4. So first we're going to find the antiderivative of x squared plus 4, which is x 3 divided by 3 plus 4x. And so we have this, that is not, from 1 to 4. So now we're going to plug in the upper limit and subtract that from the lower limit.
Oh, so that's the f of b minus
Yes,
f of
yeah.
a.
So yes, 4 is f of b, so f of 4 minus f of 1. So let's do that. So we'll have 4 thirds over 3 plus 4 times 4, all minus 1 cubed over 3 plus 4 times 1, which is 64 thirds plus 16 minus 1/3 plus 4. And after doing all the math, you're going to get a total of 33.
And that's just your answer?
That's your answer right there.
Okay, I understand that.
Awesome. Okay.
So how would you use this in the real world?
Well, okay, one is, let's say you are on a second story of an apartment building or house, and you're throwing a ball down to your friend who's at the bottom, and you want to find out the total distance it traveled. So you could set up a problem with, let's say the function is negative 2x plus 4. And so we're going to solve that. I'm going to have you solve this one by yourself after what we've learned. So how do you think you'd set it up?
So you would set up the integral from 0 to 2, and you would put in the function negative 2x plus 4. Is that correct?
Yes. You don't want to forget to put the dx on the end to clarify that.
Okay.
But yes.
And then you would take the antiderivative of the function, so it would be negative 2x squared over 2 plus 4x.
Yeah.
And that would go to negative x squared plus 4x, which you evaluate from 0 to 2. Okay, then you would plug in 2 minus when you plug in 0.
Yes.
So it would be negative 2 squared plus 4 times 2 minus negative 0 squared plus 4 times 0. And you would get negative 4 plus 8 minus 0 plus 0. So then you would just have 4 for your answer. Is that right?
That's right, yep. So that would be the total distance the ball traveled from you to your friend.
Okay.
So that's how you'd use it in a world of a problem. It can be used for other things as well.
That's cool.
Yeah. Does it all make sense?
Yes, it does. Well, thank you so much for teaching me the first and second parts of the fundamental theorem of calculus.
Yeah, of course. I'm glad I could help.
Yeah, well, gotta head back to 2017.
2017?
Yeah, I'm from the future.
Wait, okay. Well, then can you do me a favor real fast?
Sure, what?
Can you tell me how the trick to time traveling then?
I actually have a lot of homework. Bye! Now I can solve my calculus homework.